Standing alone on one of the world's most prized pieces of oceanfront property and lit up like a 4.5 million pound candle, Space Shuttle Discovery is fully fueled and ready for its early morning liftoff from Launch Pad 39A here at Kennedy Space Center in Florida. Discovery's bright orange external tank is filled with more than 500,000 gallons of liquid hydrogen and liquid oxygen. The shuttle's power-producing fuel cells, general-purpose computers, and life support systems are all activated and everything is working as expected. About 3.5 miles away from Discovery, launch controllers in Kennedy's Launch Control Center Firing Room 4 are overseeing all of the shuttle systems and verifying the step-by-step processes that will lead to an expected liftoff at 6:21 and 25 seconds a.m. Eastern Daylight Time. Discovery's crew is awakened at 8 p.m. Easter Sunday, ate breakfast at 8:30, underwent standard medical checks at 9 o'clock, and has been making last-minute preparations for this morning's launch attempt. This will be the 35th night launch in Space Shuttle program history, and as the shuttle rockets to the northeast, it will make an early morning wake-up call to residents of the Space Coast as well as much of America's East Coast as it climbs and accelerates to 17,500 miles an hour in just 8.5 minutes. Right after the launch tower is cleared, Discovery will perform a roll maneuver pointing it precisely on the trajectory of 51.6 degrees to catch up to the International Space Station. At the time of liftoff, the station will be about 220 miles over the Atlantic Ocean, southwest of Ireland. But about 17 minutes before launch, at 6:04 a.m., the space station will pass over the Kennedy Space Center, providing an excellent sighting opportunity as it moves from the south-southwest to the east, and it should be visible for about 3 minutes, peaking at a 43-degree elevation. Space Shuttle Discovery is launching on STS-131, a 13-day mission to deliver new science materials and experiments, and also to replenish supplies for the 6-person space station crew. The Leonardo multi-purpose logistics module in Discovery's payload bay is filled with racks totaling more than 17,000 pounds, and there also are nearly 7,000 pounds of supplies, including parts for the station water systems, wastewater filters, food, and clothing. The work to transfer the racks and supplies will occupy much of the combined shuttle and station crew's time while the two spacecraft are docked on the mission. STS-131 also will include 3 spacewalks to install a spare ammonia storage tank and return a used one, switch out a gyroscope on the station's truss or backbone, and retrieve a Japanese experiment from the station's exterior. For the first time in history, 4 women will work aboard the same spacecraft at the same time. STS-131 mission specialist Stephanie Wilson, Dottie Metcalf-Lindenberger, and Naoko Yamazaki will join Expedition 23 crew member Tracy Caldwell-Dyson for a week of docked operations. Tracy just arrived at the station early Sunday morning when the Soyuz rocket she launched on from Kazakhstan docked to the space station. Twice before, 3 women have flown aboard the space shuttle. On STS-40 in 1991, Tammy Jernigan, Ray Seddon, and Millie Hughes-Fulford flew on Columbia. And on STS-96 in 1999, Ellen Ochoa, Tammy Jernigan, and Julie Payette flew aboard Discovery. This also will be the first time 2 Japan Aerospace Exploration Agency astronauts will be in space at the same time. Expedition 23 crew member Suichi Noguchi awaits the arrival of Discovery mission specialist Naoko Yamazaki. Naoko is the second Japan Aerospace Exploration Agency woman astronaut to fly. The first was Chiaki Mukai. Sunday night at 8:15, NASA's Space Shuttle mission management team met to assess our readiness to fill Discovery's external tank and gave a go for that operation to commence. The work was scheduled to begin at 8:56 p.m., but actually got underway at 9:28 p.m. after engineers took some time to assess a voltage spike that was observed on fuel cell number 2. The spike did not exceed limits and has not repeated, and we'll keep an eye on it as we continue on towards launch this morning at 6:21 a.m. Tanking operations proceeded normally, and they were completed about 3 hours later. So here inside the Launch Control Center, the countdown for Discovery's launch is continuing on schedule. The launch window opens at 6:16 and 25 seconds, and our preferred and planned launch time is exactly 5 minutes later at 6:21:25. The launch window for a Flight Day 3 rendezvous closes at 6:26 and 25 seconds, and for a Flight Day 4 rendezvous 3 minutes later at 6:29 and 35 seconds. NASA managers have determined that they would use the Flight Day 4 opportunity if it became necessary. We're at T-minus 3 hours and holding. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding, with a little bit more than an hour remaining in this hold. Space Shuttle Discovery last flew STS-128 in September of 2009, landing back at Edwards Air Force Base in California. And after a cross-country ferry ride back here to Kennedy Space Center, Discovery has been under the watchful eyes of Stephanie Stilson, getting ready for today's launch. Stephanie is Discovery's flow director, and we'd like to welcome you here with us this morning.
Well, thank you, Mike. It's great to be here at this early morning hour.
It is. We're looking forward to an awesome launch a little bit later on. You've been Discovery's flow director for some time now.
Yes, I actually joined the shuttle processing team in December of 2000, and this is actually my 10th mission that I've worked. I started out with STS-102, so I'm on number 10 now.
Excellent. And prior to becoming the flow director, what roles did you have here at Kennedy Space Center?
Well, within shuttle processing, I started out as Discovery's NASA vehicle manager, and then in 2005 we reinstated the flow director role, and luckily I was selected to be the flow director for Discovery as well. Prior to that, I worked at International Space Station. I was a test director for the multi-element integration testing that we do here at Kennedy Space Center.
Excellent. And at what point during a flow do you become responsible for the vehicle?
My role really starts at the end of the mission. So as soon as we touch down, whether that be at Kennedy Space Center or at Dryden, wherever, that's when our processing flow starts. So that's where I begin. And really follow Discovery all the way through the processing, also with the boosters in the tank, and all the way up to launch. And then get to take a little bit of a break, and then get ready to start the next flow.
And as we've been getting ready for STS-131, has this been a relatively clean flow?
It has. It's been a relatively stable flow, especially compared to some of our previous flows in the near past. I really attest that to the great shape the vehicle is in, the great work the team has done here to really take very good care of Discovery. And I'm going to talk about a few of the off-nominal things that we did during the video clip, so we'll cover those then. Okay, so let's go ahead and roll the video. As Mike mentioned, Discovery landed at NASA's Dryden Flight Research Center in California after STS-128 and was ferried back to Kennedy Space Center in preparation for this current mission. The majority of the work is prepared the orbit for flight occurring in the orbiter processing facility. Here we see technicians removing a gaseous nitrogen tank from the starboard side of the payload bay. As you can see, a crane is lifting the tank out of Discovery's midbody. This work was done for weight savings in preparation for Discovery's next mission, STS-133, slated for September. The orbiter's 3 Space Shuttle main engines are removed and replaced after each flight. Discovery's main engines were removed in early October and installed in early December of last year. Each engine is 14 feet long and 7.5 feet wide and weighs approximately 7,000 pounds. Combined, the 3 main engines provide 375,000 pounds of thrust during liftoff. The yellow piece of equipment that you see here is a modified Heister forklift that we use to remove and install the main engines. Each engine is transported from the Space Shuttle main engine shop to the orbiter processing facility for installation. Installing the engines is a very slow and methodical process of ensuring everything is lined up correctly as the engines are inserted into the aft compartment. Technicians, engineers, safety, and quality personnel closely monitor this critical task. The engines are ignited 6 seconds before liftoff when the fuel, liquid hydrogen, is combined with liquid oxygen. Here we see the removed forward reaction control system at the hypergolic maintenance facility at Kennedy Space Center. During Discovery's previous mission, a thruster in the forward reaction control system did not perform as expected. Therefore, it was necessary to change out that thruster prior to Discovery's next flight. Doing so required removing the forward reaction control system and transporting it to the hypergolic maintenance facility. Once all maintenance activities were completed, the forward reaction control system was carefully transported back to the orbiter processing facility for reinstallation. The yellow component that you see here is a holding fixture used to lift the forward reaction control system. Here we see the front portion of the orbiter where the forward reaction control system is located.
And what does the forward reaction control system do, Stephanie?
It actually works in conjunction with the orbiter maneuvering system in the back of the orbiter to generate thrust for velocity changes and attitude control on orbit and during reentry. Here you see a technician performing a tile repair on the underside of the orbiter. There are approximately 24,000 tiles on the vehicle. Every tile is inspected following each mission and repaired or replaced as required. The day after Christmas, the external tank was delivered by barge to the Kennedy Space Center from the Michoud Assembly Facility in Louisiana. Once on dock, we used the external tank transporter to move the tank off the barge and over to the vehicle assembly building. While the entire offload process takes technicians and engineers approximately 2 hours, the actual travel time is only 10 minutes for the quarter-mile trip. The tank is 154 feet long, 27.5 feet in diameter, and holds over 500,000 gallons of propellant. The function of the external tank is to provide liquid hydrogen and liquid oxygen to the 3 Space Shuttle main engines. The outside of the tank is covered in a polyurethane foam that protects it from extreme temperature variations. Once in the vehicle assembly building, we begin the slow and careful process of lifting the external tank into the vertical position and placing it in the checkout cell. The empty external tank weighs approximately 58,000 pounds and is lifted by massive overhead cranes in the vehicle assembly building.
Stephanie, when the tank is fully loaded, how much does it weigh?
The external tank weighs roughly 1.65 million pounds when fully loaded with liquid hydrogen and oxygen. Here you see the aft bipod struts and the propellant feed lines where the external tank connects to the orbiter's aft. Following standalone inspections and processing of the external tank, it's ready to be lifted out of the checkout cell and into the integration cell where it can be mated to the solid rocket boosters. Transport of this delicate flight hardware requires numerous support personnel to ensure careful and safe maneuvering. The forward tips of the solid rocket boosters can be seen here as the external tank is being lowered into position for mate. The tank is now in its final position, mated to the solid rocket boosters. Once all maintenance and checkout is complete in the orbiter processing facility, Discovery is carefully backed out and transported to the vehicle assembly building. While the distance from the orbiter processing facility to the vehicle assembly building is less than half a mile, the trip takes approximately 30 minutes. During the rollover for STS-131, the crew made an unexpected visit and joined our team in escorting Discovery over to the vehicle assembly building. It was great to have the crew here for such an important processing milestone. Once safely in the vehicle assembly building, we begin the process of lifting the orbiter off the transporter and attaching it to the external tank. A yellow sling is connected to the orbiter so that cranes can lift Discovery and move it into the vertical position. Lifting the 200,000-pound orbiter requires use of a 325-ton crane and a 250-ton crane. Once Discovery is hanging in the vertical position, the smaller of the two cranes is disconnected and the larger crane lifts the orbiter up and over the transom into the integration cell. It takes approximately 12 hours to lift the orbiter and get it into the mate position. Technicians closely monitor the movement of the orbiter and are in radio contact with the crane operators at all times. Here you can see the Space Shuttle main engines with their red protective engine covers that are removed before flight. The completed Space Shuttle vehicle is moved by one of our 2 crawler transporters. Instead of wheels, the crawler has 8 tracks with 57 cleats per track. Each cleat weighs 1 ton. The crawler weighs 6 million pounds and uses 150 gallons of diesel fuel per mile as it travels down a gravel path out to the launch pad. The crawler is 131 feet long by 114 feet wide, which is comparable in size to the infield of a regulation baseball field. The gravel crawlerway is 130 feet wide, roughly the width of an 8-lane highway. At a speed of less than 1 mile per hour, it takes approximately 8 hours to travel just over 3 miles from the building to Pad A. Discovery was delivered to launch pad in the morning on March 3rd. Once at the launch pad, we spent about a month doing a full system checkout of the tank, boosters, and orbiter in preparation for launch.
You know, one question a lot of people have is why does the left-hand solid rocket booster have a thick black stripe at the top, and the right-hand one does not.
That was something I learned just recently myself. The solid rocket boosters actually, once they're expended, they're jettisoned from the external tank and fall into the Atlantic Ocean. We have 2 retrieval ships that recover the boosters and tow them back to the Cape Canaveral Air Force Station. The unique stripe that you mentioned is on the left-hand booster, allowing the 2 retrieval ships to differentiate between the left and the right booster as they descend from the sky and eventually splash down in the ocean. The team that prepares Discovery for flight is the best that there is out there, and I'm very honored to work with each and every one of them. We are all looking forward to the successful launch of 131, and followed by the opportunity to prepare Discovery for her final flight later this year.
That's awesome, Stephanie. It's a wonderful occasion. It's the end of a great process, and it's an incredible process every time we get an orbiter out to the pad, and it's a pleasure to talk with you once again.
Well, thank you. It's been a wonderful processing flow, and we're looking forward to a wonderful launch and a wonderful mission.
Great. Thank you again. This is shuttle launch control at T-minus 3 hours and holding. 47 minutes, 20 seconds remaining in this hold. Discovery is going to be carrying what has been described as a moving van in its payload bay. The Leonardo Multi-Purpose Logistics Module, or MPLM, is outfitted with experiment racks to enable the space station astronauts to continue maximizing their utilization of the station for science. And with us to talk about the payloads aboard Discovery is STS-128 payload manager Joe DeLay. Good morning, Joe.
Good morning, Mike. How are you?
I'm doing great. Thank you for being with us.
Oh, it's an honor. Thank you.
So you've been tracking this mission for some time, I suspect.
Oh, yes. We've been working on it about 1.5 to 2 years. It's been a long time, but we're excited and we're very glad to be here, and I'm sure we'll have a good launch.
Well, it's an important mission, and we're wondering if you could just fill us in a little bit about the payloads for the mission.
Oh, you bet. As I mentioned, we're very excited about the mission as we approach assembly complete for ISS these next few missions. So we're going to have the MPLM. We're carrying the MPLM up, which is the pressurized logistics module. It's going to have 16 racks. As you can see right here in the SSPF, the Space Station Processing Facility, between us, Boeing, and our NASA friends, we're integrating in and testing the module with all the different science racks and storage racks that can go inside. So we'll have 16 racks. We're going to have 11 storage racks, 4 utilization of science racks, and 1 crew quarters rack. And then the whole weight of the pressurized logistics module will be about 20,850 pounds. So right now what we're doing is we're actually taking the racks after they've been integrated and testing them, and we're stowing them inside the pressurized logistics module. And like I mentioned, we have 16 racks, so this takes some time. And here's a picture of one of our 11 storage racks that's about to be installed into the pressurized logistics module. We're going to be carrying up about 7,000 pounds of storage to continue, supporting our astronauts on the ISS. And this whole operation takes about, from beginning to end, takes about 3.5 months before you start testing the racks, integrating them, and getting them all installed into the pressurized logistics module. So we're looking forward to the flight. On flight day 3, we're going to be docking. On flight day 4, we'll actually install the module, as you can see right now, onto the ISS. In a few minutes, we'll see a picture of an ammonia tank, which we'll be installing on flight day 7. So this is called a 0G storage rack, which is a rack that goes in folded, and once on orbit, it can be installed to expand, and they can use that for additional storage on the International Space Station. Here's a good picture of all the storage racks and some of the science racks in the module. This external view, you can see the hatch is still open as the team prepares the module for flight. Then towards the end, we have to perform all sorts of inspections, including a black light inspection, to make sure we have no FOD, no dirt inside the module. We want to keep it all clean for when it gets on space. And now we're getting prepared to close the hatch. And then once we close the hatch, we go ahead and pressurize the module, and we declare it ready for flight. So as we mentioned, some of the racks are going to be that we've installed inside the module. One is called the MARES, which is a muscle atrophy research and exercise system. So this will perform research on the musculoskeletal system to better understand the effects of microgravity on the muscular system, and this will be transferred from the module into Columbus. And I mentioned the crew quarters rack. This will actually the 4th time we've flown one, and this will be stowed in Harmony. Now in this picture we have the ammonia tank, which we call the ATA, and it weighs about 4,000 pounds, and its purpose is to bring up about 600 pounds of ammonia, and it's used to help for the cooling system of the radiators on the ISS, and then once on orbit that will be placed on the S1 truss. So once we have our external carrier with the ammonia tank inside the canister, we put the module, pressurized module in the canister, and we'll rotate it to the horizontal position, and we'll be going to the pad and install it in the payload changeout room, and eventually that will be installed inside the orbiter. So another rack we're flying up is called Express Rack 7, and that will be transferred to Destiny. And Express Rack 7 streamlines the process of transporting experiments to the ISS. Another rack we're flying is Melfi, and that is going to be installed into the GEM module, and that's basically a -80-degree laboratory freezer, and ESA built the freezer to store samples. And as we bring the canister to the pad, it takes a few hours. You have to go nice and slow, and then once we get to the pad, you'll see it's being lifted to the payload changeout room. Another rock we're going to be flying up is called the Wharf. It's a window observation research facility, and it's almost like a dark room, and it has power, data, and cooling to support the highest quality optics ever flown on a human space aircraft. So this rack will actually be installed in front of a special window in the Destiny lab, and will allow the crew to perform experiments and take fantastic pictures of space and of Earth. So now we have the canister and the payload installed into the PCR, and here's a good picture of the payload MPLM and the LMC in the orbiter, and it looks like the team is getting ready to close the doors for flight. And also, besides the pressurized module and the ammonia tank, we're going to be flying up some mid-decks, some science mid-decks, and I'll just briefly mention a few of those. We're going to be flying up the Space Tissue Loss mid-deck, which is sponsored by the Walter Reed Army Institute, and the purpose is to study the effects of microgravity on the immune system. We're going to be flying up the NPL Vaccine 8, which is a payload in support of the National Lab Pathfinder Initiative, and that'll be used to examine the development of potential vaccines for prevention of infections on Earth. We'll be flying up a KSC payload called the BRIC. That's a biological research experiment which will study plants to see which are best suited for long-term space flight. Another nice one we're flying up is called the Space Seed, and that's a JAXA experiment which will yield important and useful information for improving the productivity of crops in space. So in this video that you're seeing now, you'll see some of our customers at KSC integrating their experiments and test them, getting ready for flights. KSC has 2 modern facilities in which the customer can use to integrate and test their payloads or experiments. And you can see here some of our JAXA friends are working on various experiments, such as the space tissue loss, which I mentioned previously, and there's an experiment called the MAYO, which is a study of microgravity on the muscles. And there you can see the NeuroRad, which is the effects of radiation on humans. So it's interesting, Mike, whether you're walking around your home or you're visiting your doctor, you're likely to come into contact with a product that is a result of the technology first developed by NASA. It starts off just like this video is showing. So since the mid-70s, more than 1,300 NASA technologies have benefited U.S. industry, improved our quality of life, and created jobs for Americans. So as we get closer to ISS, to assembly complete, we'll continue and increase our science capability on ISS to benefit mankind on Earth.
It's a great story, and it is going to put us on a path to continue station operations for many, many years to come. Lots of science is ahead of us.
It's great, Mike. Some examples that we've done in the past is, transportable oxygen system for air rescue. We have the ND analyzer, which is a cancer detection device. Technology used for the artificial heart. I mean, the list is really endless, and it all starts just like you saw in that video. So we're excited, and we're looking forward to this launch, and I'm sure it's going to be a great early morning.
Excellent. Thank you once again, Joe.
Thank you, Mike. It's been an honor.
Take care. This is Shuttle Launch Control. We are now taking live pictures of Discovery's astronauts in the crew quarters at the Operations Checkout Building as they are getting into their orange launch and entry suits and preparing for their trip out to the pad. It's pilot Jim Dutton being assisted with his orange ACES suit, getting the gloves on. Mission Specialist 1, Rick Mastracchio, looking at ease, confident and ready to fly today. And Clay Anderson, Mission Specialist number 5, a veteran of a long-duration space station flight, getting ready for his mission. He'll be one of 2 spacewalkers along with Rick Mastracchio on STS-131. Mission Specialist number 3, Stephanie Wilson. She's a veteran of 2 space flights, STS-121 and STS-120. Thumbs up, she's ready to go. And our Japan Aerospace Exploration Agency astronaut, Naoko Yamazaki. A big wave for the cameras and a thumbs up. She's one of 3 Discovery women astronauts who will be joining a female aboard the International Space Station. There's Dottie Metcalf Lindenberger. She's Mission Specialist number 2, making her first space flight. She's a former high school science teacher turned astronaut, and she looks very excited. Commander Alan Poindexter and the crew is very nearly ready to begin their walkout to Launch Pad 39A, where Space Shuttle Discovery stands illuminated by xenon light, ready for a launch at 6:21 a.m. Eastern Time. With 24 minutes remaining in our hold at T-minus 3 hours and holding, this is Shuttle Launch Control. And we see the astronauts for Discovery's STS-131 mission waving at the camera. Excited to be heading towards the elevator. That means they'll be on their way out to the launch pad aboard the Astrovan shortly. Several management astronauts in trailing them. The Astrovan awaits their arrival. It will be about a 25 to 30 minute ride out to the launch pad. Friends and co-workers standing by outside of the door, awaiting the astronauts, ready to cheer them on as they make their way out to begin STS-131. Over 100 news media await the arrival of Discovery's crew, and here they are.
Hands, get back, get back.
And the crew is making its way aboard the Astrovan, receiving long cheers from friends, family, news media in attendance. The crew is on its way out to Launch Pad 39A, where Space Shuttle Discovery awaits their arrival, as do members of the closeout crew. And they're on their way. The STS-131 flight crew is making its way out to Launch Pad 39A aboard the Astrovan. And here in the Launch Control Center, we are very pleased to be joined by NASA astronaut Kay Heyer, a veteran of 2 space flights and a captain in the U.S. Navy, and a native of Mobile, Alabama, and you call Merritt Island, Florida home, and you're stationed in Houston, Texas at the Johnson Space Center, so you've got 3 of the human spaceflight centers covered.
That's correct, and it's great to be here for the launch of STS-131. So we have a couple of astronauts that are with the crew and stay with them up until this point, and then they, like you said, they'll stop and let them out so they can come up into the Launch Control Center with us and with the management teams here and watch the launch and be ready to weigh in on any decisions if required. But I hear the count's going very, very smoothly, so we don't anticipate any issues at this point.
That's always good news.
It certainly is, and I'll tell you, it just gives the crew just a great sense of confidence. You know, they've trained for a long time and they're ready to go, but to actually get up to their launch morning here and to know that the vehicle is in great shape and the launch is going smoothly, that is just a very nice vote of confidence and just gives them a good extra boost.
Yeah, I imagine a lot goes through your mind at this point as you're riding the Astrovan out to the launch pad, and you know that this is the day that you've been waiting for, especially for the first-time flyers.
Oh, especially for the first-time flyers, you're correct, because this is a all new experience. Now, they've practiced this. They did a terminal countdown demonstration test a couple of weeks back, and they actually practiced this, but they didn't do it at night. So suddenly everything looks a little different at night. Here we see the Astrovan stopped as some of the management astronauts are getting off right there at the Launch Control Center. So from here out, once the Astrovan starts moving again, it's the crew inside, the driver of the van, and one of our technicians who helps insert and strap in the crew inside the Space Shuttle orbiter. There's quite a team here at the Kennedy Space Center. They basically take over the Space Shuttle orbiter from the time that it lands, and they establish cooling on the orbiter, which would be ground-provided cooling after landing, and then all the way through the ground processing, the turnaround and preparations again for the next launch. And once the Space Shuttle clears the launch pad, Then in Houston at the Johnson Space Center, Mission Control will take over and will be in charge of the Space Shuttle until such time as they hand it back to Kennedy Space Center on the runway after landing. Here we're finally seeing a good view of the Space Shuttle. The crew doesn't quite see it like this. This is kind of from the side. They'll see it approaching right head on. Here's the Astrovan pulling up to the surface of the pad. The crew will be able to get out and actually take a look at this vehicle, and let me tell you, it just looks majestic when you're standing all the way down on the pad surface and looking up at it. And it's a wonderful feeling knowing that this is that great machine that's going to take you to space and let you get on and do the work that you've been training to do.
Yeah, I imagine there's a great deal of anticipation at this point, the culmination of all the hard work that you've made as an individual and as a member of the team, the crew, leading to this point.
That's correct. You know, a lot of people have asked me, you know, what does it feel like, you know, to be going out there? And I think it must feel like game day. I've never been an Olympic athlete, but I imagine it might be very similar to an Olympic athlete finally being able to compete, because we have these tremendous teams behind us supporting us, and just as we do here at NASA. And we see the crew now out of the Astrovan, and they're walking over so they can get a better look at this beautiful Space Shuttle Discovery.
There we can see some of the venting that you were talking about.
And they just need to walk a little further over here so they can get a good view, and there's another view looking down at them. Now, already inside the Space Shuttle Discovery at this point is our astronaut support personnel, and see they're actually waving up to him. I think he's waving down at them.
I see.
We'll see him later on. He'll be wearing number 2 in a white suit, and his name is Chris Cassidy, another astronaut from the office who is making sure that the Space Shuttle orbiter is all prepared for the crew as they arrive. You'll notice that the crew's taking pictures. We really like to take pictures.
Are you taking pictures of each other? Is that what they're doing, or are they taking pictures of the shuttle?
They're taking pictures of the crew, actually. They just when it looks like they're pulling somebody over there to help them get a picture of the entire crew with the shuttle in the background. As you can imagine, we've got only a couple of minutes to get an opportunity to get a picture like this.
It's a very rare photo op.
Yes, it is, and it's, you know, it's so worthwhile. A lot of times people may say, oh, why are you stopping to take time to do that? But like you said, it's a very, very rare opportunity to get this photograph, and we also hope that all our viewers and listeners enjoy the photographs that we take as well.
And we're looking at the 3 women astronauts who are going to fly on STS-131. Stephanie Wilson, Dottie Metcalf-Lindenberger, and Naoko Yamazaki. sharing a few moments to themselves before we begin the boarding process.
Yeah, and it's so helpful to have recommendations from veteran flyers. Here we see Stephanie Wilson, a veteran astronaut, of just providing probably some tips and hints to two of the rookies on the crew. And here we see a view from the white room, which is just outside the hatch of the shuttle. And we have the commander, Alan Poindexter.
Sending greetings to his family.
And commander of the Discovery is Alan Poindexter here. He's a Navy captain, and he's on his second flight here. You're seeing him get into a harness. This harness will hook into his parachute. We have emergency survival equipment inside that harness. If it looks uncomfortable, it kind of is, but we get used to it because we train with it so much.
And as traditionally happens, the commander will be the first aboard.
That's correct, and everybody out there has a very specific job. Here's Dex giving everybody a little bit of a so long handshake. We now have a view inside the Space Shuttle Discovery. And you also heard that the commander is on board. That call was from the closeout crew, letting the Launch Control Center team know that Commander Poindexter is on board. And now we see Mission Specialist Clay Anderson. Clay will be sitting on the mid-deck. So here they've got his parachute harness on him, and they're just putting in some light sticks. Clay's giving a shout out to all his family and friends. We've changed the view back now, as you see Alan Poindexter, the commander, in his seat. And if he looks like he's laying down, well, he kind of is, because with the orbiter in the vertical position, the seats are back, so you're actually laying on your back.
Copy. I can give you 621. Copy. 622 and 623. Copy all.
OTC, OVCC.
Go ahead.
MS5 on board at this time.
Copy that. GMT 0704.
And I'm sorry, but can you give me commander's time also, please?
GMT of 0702.
Okay, and so we have Clay Anderson on board, and now we've got a view of our pilot, Jim Dutton.
This is ISL.
Jim is one of the rookie flyers.
That's correct. He's on his first flight, but boy, you'd never know it. He has been training for so long for this, and he's just a natural at it.
Please. Copy.
Well, he certainly has a lot of flying experience. He has over 3,300 hours in more than 30 different aircraft to his credit.
Now we actually have a view from inside the mid-deck of the Space Shuttle. And we see the insertion tech number 7. That's Ray Cuevas in the white suit with the number 7 on the back. He's actually strapping in Mission Specialist Clay Anderson into the mid-deck. And again, if it looks like it's tilted or rotated, well, it really is.
Okay, back to Jim Dutton. And they're inserting light sticks into his ACES suit as well.
In your view right now, on the closer part of the view, you see Stephanie Wilson.
Yep, Stephanie's making her third space flight. She flew on STS-121 first and STS-120 second.
Go ahead.
She has a bachelor's degree from Harvard and a master's degree from the University of Texas, and is Mission Specialist 3 on this mission.
I can give you steps 593 through 599.
And she's also quite the wizard at operating robotic arms.
OTC, CBSE.
That's a good trait to have.
It sure is, especially with all the work that we need to do at the International Space Station. We've got a view now back onto the flight deck, and we see Alan Poindexter putting his gloves on now. Hey, now we got Stephanie Wilson giving a shout out to her family. And that's always a fun thing to do.
Houston, CDR, com check.
CDR, Houston, we read you loud and clear. Good morning, Dex.
And Rick Mastracchio is getting ready to board.
OTC, COFC.
Go ahead.
Yeah, I can give you 16627.
He's a veteran of 2 previous space flights on STS-106 on Atlantis and STS-118 on Endeavour, where he conducted 3 spacewalks in August 2007.
In the meantime, we just changed our view back to inside the crew module on the flight deck. Now you're seeing our pilot. So we actually moved the camera over to the other side, and we're seeing our pilot, Jim Dutton. He also goes by call sign MASH.
OTC, OVCC.
Go ahead.
MS3 on board at this time.
Copy that. GMT is 0724.
And that's Stephanie Wilson is on board. We see Naoko Yamazaki in the foreground.
Back now to this view on the middeck, we see Stephanie Wilson climbing up into her seat. Her seat on the middeck is actually the one that's closest to the hatch. There are 3 seats located on the middeck, and you can see Clay Anderson is closest to us, and then there's another seat in the center that's not quite visible right now.
Houston, PLT, com check.
PLT, Houston, we read you loud and clear. Good morning, MASH.
Good morning, CJ, loud and clear.
OTC has CDR and PLT ingress complete. Request a go for post ingress switch reconfig per the S checklist.
You've got to go.
Inward.
And we just heard pilot Jim Dutton do his communications checks with the NASA test director, Steve Payne, and also again with the capsule communicator, Capcom in Houston, CJ Sturkow.
And OTC, OVCC, MS1 on board at this time.
And there's Naoko. She has a sign for her loved ones as well. And she has a big grin on her face.
And a big go STS-131.
She's going to be the load master for the mission. That means she gets to be in charge of all the multitude of payload transfers that will be occurring. This is going to be a very busy mission. And she's waving.
Yes, Naoko has a big job ahead of her.
She also will be helping Stephanie with the installation of the multipurpose logistics module.
The view that you're seeing now is in the flight deck of the Space Shuttle. We've moved the camera now. It was over there right by our pilot, Jim Dutton, but now we've moved it to the very center of the dash, if you will, up by the windshield, looking back down. And so that way we'll be able to see. If you, it's kind of hard to see, but look closely, it's a little bit dark. You see Rick Mastracchio is in his seat and he's being strapped in. And that would be on the left side of your view.
There's Dottie Metcalf-Lindenberger. She is a rookie. She is one of 3 former school teachers selected as mission specialists in the 2004 Educator Astronaut class, along with Joe Acaba and Ricky Arnold, who both flew aboard Discovery on STS-119 in March 2009.
Com check.
MS5 OTC, I've got you loud and clear. Good morning, Clay.
Good morning, Lori. I have you the same. And MS5, com check.
MS5 Houston, we read you loud and clear. Good morning, Clay.
CJ, I have you the same.
OTC, OVCC.
Go ahead.
MS4 on board at this time.
GMT 0743.
Morning, Lori. Loud and clear also. Morning, Steve. Loud and clear also. Houston, MS1, com check.
MS1 Houston, we read you loud and clear. Good morning, Rick.
Good morning, CJ. Loud and clear also.
Or spacecraft, or even like a lot of our folks have military flying experience. There was quite a big learning curve for Dottie, but she sure stepped up to it and is just fantastic.
MS2 on board at this time, and that is all crew members on board.
Copy. GMT is 0747. Check on air to ground 2. How do you read?
CDR, loud and clear. PLT, MS1.
MS2. MS3. MS4.
MS5.
I copy. All switching to ICOM A.
And we see the space station traveling over the Kennedy Space Center on NASA television. It just passed the moon. A bright dot in the sky.
Go for launch. OTC?
OTC is go.
TBC?
TBC is go.
PTC?
PTC is go.
LPS?
LPS is go.
Houston flight?
Houston flight is go.
Mila?
Milo's go.
STM?
STM is go.
Safety console?
Safety consoles go.
SPE?
SP is go.
LRD?
LRD is go.
SRO?
This is SRO, please stand by.
And CDR? Discovery is go.
NTD SRO.
Go ahead. Go ahead, SRO.
SRO is go. You have range clear to launch.
Copy, go from SRO, thank you. And Launch Director, NTD. Launch Director, go ahead. Launch team is ready to proceed. I copy that. I will conduct my poll. KSC Processing, Chief Engineer, verify no constraints to launch.
No constraints.
Copy that, thank you, Steve. KSC Shuttle, Safety and Mission Assurance.
KSC SMMA is go for launch, Pete.
Copy, Terry, thank you. Payload Launch Manager. Pete, the ISS Processing Team is go. Copy, thank you, Bill. Range weather.
Weather has no constraints for launch.
Copy, thank you. Kathy, and Ops Manager.
Pete, looks like a great morning. You're go to launch 131.
Copy that, thank you, sir. Discovery, Launch Director. Go ahead, sir. Obex, the vehicle is clean, weather is good, and this team is ready. It is time for you to rise to orbit. Good luck and Godspeed.
Thanks, Pete. The crew of STS-131 is really honored to represent the thousands of dedicated people that make up all the entire NASA, JAXA, and contractor workforces. We're flying on the most capable and versatile spacecraft ever built, and we'll see you in a few weeks. Let's do it.
Copy that. Thank you, sir. NTD, Launch Director, you do have a go to launch Discovery. Copy, thank you. Go to proceed with count.
2 minutes, 30 seconds remain in our hold, and everyone is go for launch. The countdown clock will start in 4 seconds. 3, 2, 1, and we are at T-minus 9 minutes and counting.
Has been initiated.
And the ground launch sequencer has been initiated. All countdown functions are now automatically controlled by the GLS computer located here in the firing room. NASA Test Director Steve Payne is about to call for the transmittal of stored pre-launch commands. At T-minus 31 seconds, the ground launch sequencer will issue a command to Discovery's onboard general purpose computer redundant set launch sequencer, or RSLS software. The command Go for Auto Sequence Start enables the RSLS to reconfigure certain onboard systems for launch.
PLT, connect essential buses to fuel cells per your checklist.
T-minus 8 minutes and counting.
PLT in work.
Pilot Jim Dutton is now flipping switches in the cockpit to directly connect the 3 fuel cells to the essential power buses.
OTC, PLT, essential buses connected to fuel cells.
Copy.
Good news, all 3 fuel cells operating normally. T-minus 7 minutes, 30 seconds.
Let's go for orbiter access arm retract.
And Discovery, OTC, it's time to light up the skies on your mission to expand scientific research on the International Space Station. Select rookies to ride a shuttle. This vehicle is about to go 17,000 miles per hour. Enjoy your ride.
Discovery copies. Thanks a lot.
Best wishes from Orbiter Test Conductor Lori Sally to the crew of Space Shuttle Discovery. T-minus 7 minutes and counting. The orbiter access arm has been retracted away from Discovery. This is the walkway used by the crew to gain entry into and out of the shuttle, and it can be returned to position within seconds should it become necessary. T-minus 6 minutes, 30 seconds and counting.
KRPS, start APU display recorders.
APU recorders are running.
PLT, perform APU pre-start.
PLT in work.
Orbiter Test Conductor gave pilot Jim Dutton a go to perform the auxiliary power unit pre-start procedure. The APUs provide pressure to the shuttle's 3 hydraulic systems, which move the main engines and aero surfaces during flight. T-minus 5 minutes, 50 seconds and counting.
OTC, PLT, APU pre-starts complete. 3 great backpacks.
Copy.
Everything normal with the APU pre-start. T-minus 5 minutes, 30 seconds. T-minus 5 minutes, 10 seconds and counting. APU activation will come in just a few seconds. T-minus 5 minutes and counting.
GLS is go for orbiter APU start.
PLT, perform APU start.
PLT in work.
The launch team has terminated liquid oxygen replenished to the external tank and is now initiating LOX drain bag.
OTC CDR heater reconfig is complete.
T-minus 4 minutes and 30 seconds.
OTC PLT APU start is complete.
Copy.
All 3 APUs are up and running. T-minus 4 minutes, 5 seconds and counting.
GLS is go for purge sequence 4.
The final helium purge of the 3 main engines is underway in preparation for main engine start. The final test of the flight control surfaces is being conducted. This is a programmed pattern of movements designed to verify the readiness for launch of all the flight control surfaces, the elevons, speed brakes, and rudder. And the main engines are being gimbaled through a pre-programmed series of maneuvers as a final test before launch. T-minus 3 minutes, 15 seconds and counting. T-minus 3 minutes and counting. Final pressurization of the external tank's liquid oxygen tank is underway.
GLS is go for ET LO2 pressurization.
And we are completing the purge of the shuttle's main engines. T-minus 2 minutes, 39 seconds and counting.
DLT, clear caution and warning memory. Verify no unexpected errors.
PLT inlet.
And the gaseous oxygen vent hood, or beanie cap, is being retracted away from the top of the external tank. T-minus 2 minutes, 20 seconds and counting.
Discovery, close and lock visors. Initiate O2 flow.
Discovery copies visors and O2 flow.
T-minus 2 minutes and counting. Liquid hydrogen replenish on the external tank is now being terminated.
GLS is go for ET LH2 pressurization.
T-minus 1 minute, 44 seconds and counting. All systems are go.
One minute, 30 seconds.
90 seconds away from the launch of Space Shuttle Discovery. T-minus 1 minute, 15 seconds and counting. T-minus 1 minute.
1 minute.
The ground launch sequencer will verify that the 3 main engines are ready to start. The booster joint heaters are being deactivated at this time. We're transferring to orbiter internal power. Discovery is now running off of its 3 onboard fuel cells. T-minus 38 seconds and counting. Coming up on a go for auto sequence start.
GLS is go for auto sequence start.
T-minus 25 seconds. Discovery's onboard computers have primary control of the vehicle's critical functions. 20 seconds.
15.
T-minus 15 seconds and the sound suppression water system has been activated.
10.
We have a go for main engine start. 3 engines up and ready. 3, 2, 1, 0. Booster ignition and liftoff of Discovery, blazing a trail to scientific discoveries aboard Space Station.
Houston Discovery roll program.
Roger, roll, Discovery.
This is Mission Control Houston. Space Shuttle Discovery is rolling into a heads-down position, putting it on course for 51.6 degree, 136 by 36 statute line orbit, and eventually the International Space Station. Discovery's 3 liquid-fueled main engines are now throttling down to reduce stress on the shuttle as it travels through the area of maximum dynamic pressure. Discovery is already at an altitude of 4.7 miles or 26,500 feet and traveling.
Discovery, go at throttle up.
Roger, go at throttle up.
Traveling 1,000 miles per hour. Discovery's engines are now throttled back up and performing at full capability. At liftoff, the shuttle weighed more than 4.5 million pounds, and now 1 minute and 27 seconds into the flight, the main engines and solid rocket boosters have reduced that weight by about half. The solid rocket boosters alone are burning 11,000 pounds of propellant per second, and the external tank is now 3,000 pounds lighter than when it began. Discovery is now 21 miles away from its launch pad and 22 miles in altitude, traveling 2,700 miles per hour. All 3 main engines are working just as expected. The 3 fuel cells are generating power, and the 3 auxiliary power units are all producing pressure. In short, everything performing well. 2 minutes and 7 seconds into the STS-131 mission.
103 converged.
The booster officer in the Mission Control Center has confirmed the solid rocket booster separation. All systems continuing to function well. Two orbital maneuvering system engines on Discovery's tail are now firing as well, providing the shuttle an extra boost into orbit. The engine burn will last 1 minute and 44 seconds.
Discovery, 2-engine TOW.
Discovery copies, 2-engine TOW.
That call indicates that Discovery can now reach Morón in Spain should one of the 3 main engines fail. However, all 3 of those main engines are currently working well. 2 minutes and 59 seconds into the flight, and Discovery is now 79 miles away from Kennedy Space Center in Florida, 48 miles in altitude, and traveling at 4,500 miles per hour. Space Shuttle Discovery also seeing the first of many sunrises of the STS-131 mission.
Discovery, Houston, you are negative return.
Discovery copies, negative return.
Discovery is now flying too high and too fast to return to the Kennedy Space Center in the event of an engine failure. That's not currently a problem, however, as all engines are continuing to perform as expected. 4 minutes and 15 seconds into Discovery's flight. Shuttle's traveling 6,000 miles per hour at an altitude of 63 miles and is 181 miles away from Kennedy Space Center. Environmental Systems Officer here in Mission Controls confirmed that the flash evaporator system has been activated to provide cooling to the shuttle system until the shuttle's cargo bay doors open and double as radiators.
Discovery, press to ATO.
Discovery copies. Press to ATO.
Should two of the shuttle's three main engines fail after this point, it can still reach a safe, though lower than planned orbit, as that call from Capcom Rick Sturco indicated. Discovery is now 5 minutes and 42 seconds into its flight.
Engine Ops 3.
Discovery, single engine Ops 3.
67 miles in altitude and 351 miles away from Kennedy Space Center, Discovery could still make it across the Atlantic for an abort landing, even if two of the three main engines failed at this point. All engines are performing well.
Discovery, single engine Zaragoza.
Discovery copies, single engine Zaragoza.
Discovery now flying more than 10,000 miles per hour, 66 miles in altitude and 430 miles away from Kennedy Space Center.
Discovery, press to MECO.
Discovery copies, press to MECO.
And that call indicates the Discovery can reach its planned orbit of 136 by 36 statute miles, even if one of the engines fails. All three engines are still working well, as are the auxiliary power units and the three fuel cells.
Discovery, you are single engine press. Your shutdown plan is nominal. Go for the plus X, go for the pitch maneuver.
Copy, nominal shutdown plan. Go for the plus X, go for the pitch.
Even if two engines were to fail at this point, Discovery could still make its planned orbit with just one. That shouldn't be necessary, however, as all three engines are still performing at full capability. Also, Capcom Rick Sturcow there letting Commander Alan Poindexter know that Discovery will cut off its three main engines as planned, and that he has the go-ahead then to pitch Discovery up to allow for photos of the external tank to be taken after its separation. Discovery now 7 minutes and 48 seconds into its mission, traveling at 15,000 miles per hour, 63 miles in altitude, and 730 miles downrange from Kennedy Space Center. The booster officer here in Mission Control is reporting that Discovery's three main engines have been shut off. We're now waiting for external tank separation.
Discovery Houston, nominal MECO, OHMS 1 is not required.
Nominal MECO, OHMS 1 not required.
And there is the external tank separation. 8 minutes and 53 seconds into the STS-130 mission. Discovery now safely in orbit, 66 miles above the Earth, and traveling at 17,500 miles per hour. Also 1,065 miles downrange from the Kennedy Space Center. Now 11 minutes and 32 seconds into Discovery's flight. Commander Alan Poindexter is maneuvering the vehicle into position to take some photos of the external tank, now separated from Space Shuttle Discovery.
T-minus 15 seconds and the sound suppression water system has been activated.
10.
We have a go for main
engine start.
Up and ready. 3, 2, 1, 0. Booster ignition. And liftoff of Discovery, blazing a trail to scientific discoveries aboard Space Station.
Discovery, roll program. Fine to roll, Discovery.
Space Shuttle Discovery is rolling into a heads-down position, leaving on course for 1.63, 136 and 136 statute line orbit, and eventually the International Space Station. Discovery's 3 liquid-fueled main engines are now throttling down to reduce stress on the shuttle as it travels through the area of maximum dynamic pressure. Discovery is already at an altitude of 4.7 miles or 26,500 feet and traveling.
Discovery, go at throttle up.
Roger, go at throttle up.
Traveling 1,000 miles per hour, Discovery's engines are now throttled back up and performing at full capability. At liftoff, the shuttle weighed more than 4.5 million pounds, and now 1 minute and 27 seconds into the flight, the main engines and solid rocket boosters have reduced that weight by about half. The solid rocket boosters alone are burning 11,000 pounds of propellant per second, and the external tank is now 3,000 pounds lighter than when it began. Discovery is now 21 miles away from its launch pad and 22 miles in altitude, traveling 2,700 miles per hour. All 3 main engines are working just as expected. The 3 fuel cells are generating power, and the 3 auxiliary power units are all producing pressure. In short, everything performing well. 2 minutes and 7 seconds into the STS-131 mission.
103 converged.
The booster officer in the Mission Control Center has confirmed the solid rocket booster separation. All systems continuing to function well. Two orbital maneuvering system engines on Discovery's tail are now firing as well, providing the shuttle an extra boost into orbit.
T-minus 15 seconds and the sound suppression water system has been activated.
10.
We have a go for main
engine
start.
start.
3 engines up and ready. 3, 2, 1, 0. Booster ignition. And liftoff of Discovery, blazing a trail to scientific discoveries aboard Space Station. Discovery's onboard computers have primary control of the vehicle's critical functions. 20 seconds.
15.
T-minus 15 seconds and the sound suppression water system has been activated.
10.
We have a go for main start.
engine start.
3, 2, 1, 0. Booster ignition. And liftoff of Discovery, blazing a trail to scientific discoveries aboard Space Station.
Discovery, roll program.
We copy, Discovery. Thanks for the update.
We have a go for main start.
engine start.
Up and ready. 3, 2, 1, 0. Booster ignition. and liftoff of Discovery, blazing a trail to scientific discoveries aboard Space Station.
Discovery, roll program.
5 to roll, Discovery.
Space Shuttle Discovery is rolling into a heads-down position, leaving on course for 1.6 degree, 136 statute orbit, and eventually the International Space Station. Discovery's 3 liquid-fueled main engines are now throttling down to reduce stress on the shuttle as it travels through the area of maximum dynamic pressure. Discovery is already at an altitude of 4.7 miles or 26,500 feet and traveling
Discovery, go at throttle up.
Roger, go at throttle up.
1,000 miles per hour. Discovery's engines are now throttled back up and performing at full capability. At liftoff, the shuttle weighed more than 4.5 million pounds, and now 1 minute and 27 seconds into the flight, the main engines and solid rocket boosters have reduced that weight by about half. The solid rocket boosters alone are burning 11,000 pounds of propellant per second, and the external tank is now 3,000 pounds lighter than when it began. Discovery is now 21 miles away from its launch pad and 22 miles in altitude, traveling 2,700 miles per hour. All 3 main engines are working just as expected. The 3 fuel cells are generating power, and the 3 auxiliary power units are all producing pressure. In short, everything performing well. 2 minutes and 7 seconds into the STS-131 mission.
103 converged.
The booster officer in the Mission Control Center has confirmed the solid rocket booster separation. All systems continuing to function well. 2 orbital maneuvering system engines on Discovery's tail are now firing as well, providing the shuttle an extra boost into orbit. The engine burn will last 1 minute and 44 seconds.
Discovery, 2 engine TOW.
Discovery copies, 2 engine TOW.
T-minus 15 seconds and the sound suppression water system has been activated.
10.
We have a go for main
Go for main
start.
engine start.
3, 2, 1, 0. Booster ignition and liftoff of Discovery, blazing a trail to scientific discoveries aboard Space Station.
Discovery, roll program.
5 to roll, Discovery.
Space Shuttle Discovery is rolling into a heads-down position, leaving on course for 1.6 degree, 100.
Discoveries aboard Space Station.
Discovery, roll program.
5 to roll, Discovery.
Space Shuttle Discovery is rolling into a heads-down position, leaving on course for 1.6 degree, 136 statute orbit, and eventually the International Space Station. Discovery's 3 liquid-fueled main engines are now throttling down to reduce stress on the shuttle as it travels through the area of maximum dynamic pressure. Discovery is already at an altitude of 4.7 miles or 26,500 feet and traveling
Discovery, go at throttle up.
Roger, go at throttle up.
1,000 miles per hour. Discovery's engines are now throttled back up and performing at full capability. At liftoff, the shuttle weighed more than 4.5 million pounds, and now, 1 minute and 27 seconds into the flight, the main engines and solid rocket boosters have reduced that weight by about half. The solid rocket boosters alone are burning 11,000 pounds of propellant per second, and the external tank is now 3,000 pounds lighter than when it began. Discovery is now 21 miles away from its launch pad and 22 miles in altitude, traveling 2,700 miles per hour. All three main engines are working just as expected. The three fuel cells are generating power, and the three auxiliary power units are all producing pressure. In short, everything performing well. 2 minutes and 7 seconds into the STS-131 mission.
103 converged.
The booster officer in the Mission Control Center has confirmed the solid rocket booster separation. All systems continuing to function well.
T-minus 15 seconds and the sound suppression water system has been activated.
10.
We have a go for main
go for main engine start.
Up and ready. 3, 2, 1, 0. Booster ignition and liftoff of Discovery, blazing a trail to scientific discoveries aboard Space Station.
Discovery, roll program.
Roger, roll, Discovery.
Space Shuttle Discovery is rolling into a heads-down position, heading on course for 1.6 degree, 136 stationary orbit, and eventually the International Space Station. Discovery's three liquid-fueled main engines are now throttling down to reduce stress on the shuttle as it travels through the area of maximum dynamic pressure. Discovery is already at an altitude of 4.7 miles.
We'll take the maneuver, Discovery.
T-minus 15 seconds and the sound suppression water system has been activated.
10.
We have a go for main
engine start.
Up and ready. 3, 2, 1, 0. Booster ignition and liftoff of Discovery, blazing a trail to scientific discoveries aboard Space Station.
Discovery, roll program.
Roger, roll, Discovery.
Space Shuttle Discovery is rolling into a heads-down position, heading on course for 1.6 degree, 136 stationary orbit, and eventually the International Space Station. Discovery's three liquid-fueled main engines are now throttling down to reduce stress on the shuttle as it travels through the area of maximum dynamic pressure. Discovery is already at an altitude of 4.7 miles or 26,500 feet, and traveling
Discovery, go at throttle up.
Roger, go at throttle up.
traveling 1,000 miles per hour. Discovery's engines are now throttled back up and performing at full capability. At liftoff, the shuttle weighed more than 4.5 million pounds, and now, 1 minute and 27 seconds into the flight, the main engines and solid rocket boosters have reduced that weight by about half. The solid rocket boosters alone are burning 11,000 pounds of propellant per second, and the external tank is now 3,000 pounds lighter than when it began. Discovery is now 21 miles away from its launch pad and 22 miles in altitude, traveling 2,700 miles per hour. All three main engines are working just as expected. The three fuel cells are generating power, and the three auxiliary power units are all producing pressure. In short, everything performing well. 2 minutes and 7 seconds into the STS-131 mission. Booster officer in the Mission Control Center has confirmed the solid rocket booster separation. All systems continuing to function well. Two orbital maneuvering system engines on Discovery's tail are now firing as well, providing the shuttle an extra boost into orbit. The engine burn will last 1 minute and 44 seconds.
Discovery, 2-engine TOW.
Discovery copies, 2-engine TOW.
It's 15 seconds and the sound suppression water system has been activated.
Okay.
We have a go for main
go for main
start.
engine start.
Engines up and ready. 3, 2, 1, 0. Booster ignition and liftoff of Discovery, blazing a trail to scientific discoveries aboard Space Station.
Discovery, roll program.
Fine to roll, Discovery.
It's 15 seconds and the sound suppression water system has been activated.
Okay.
We have a go for main
go for main
start.
engine start.
Engines up and ready. 3, 2, 1, 0. Booster ignition and liftoff of Discovery, blazing a trail to scientific discoveries aboard Space Station.
Discovery, roll program.
Fine to roll, Discovery.
Space Shuttle Discovery is rolling into a heads-down position, leaving on course for 1.63, 136 by 36 statute orbit, and eventually the International Space Station. Discovery's three liquid-fueled main engines are now throttling down to reduce stress on the shuttle as it travels through the area of maximum dynamic pressure. Discovery is already at an altitude of 4.7 miles or 26,500 feet, and traveling
Discovery, go at throttle up.
Roger, go at throttle up.
1,000 miles per hour. Discovery's engines are now throttled back up and performing at full capability. At liftoff, the shuttle weighed more than 4.5 million pounds, and now 1 minute and 27 seconds into the flight, the main engines and solid rocket boosters have reduced that weight by about half. The solid rocket boosters alone are burning 11,000 pounds of propellant per second, and the external tank is now 3,000 pounds lighter than when it began. Discovery is now 21 miles away from its launch pad and 22 miles in altitude, traveling 2,700 miles per hour. All three main engines are working just as expected. The three fuel cells are generating power, and the three auxiliary power units are all producing pressure. In short, everything performing well. 2 minutes and 7 seconds into the STS-131 mission.
103 converged.
The booster officer in the Mission Control Center has confirmed the solid rocket booster separation. All systems continuing to function well. Two orbital maneuvering system engines on Discovery.
We have a go for main
engine
start.
start.
Engines up and ready. 3, 2, 1, 0. Booster ignition and liftoff of Discovery, blazing a trail to scientific discoveries aboard Space Station.
Discovery, roll program.
Fine to roll, Discovery.
Space Shuttle Discovery is rolling into a heads-down position, leaving on course for 1.63, 136 by 36 statute orbit, and eventually the International Space Station. pressure. Discovery is already at an altitude of 4.7 miles or 26,500 feet and traveling.
Discovery, go at throttle up.
Roger, go at throttle up.
Traveling 1,000 miles per hour. Discovery's engines are now throttled back up and performing at full capability. At liftoff, the shuttle weighed more than 4.5 million pounds, and now 1 minute and 27 seconds into the flight, the main engines and solid rocket boosters have reduced that weight by about half. The solid rocket boosters alone are burning 11,000 pounds of propellant per second, and the external tank is now 3,000 pounds lighter than when it began. Discovery is now 21 miles away from its launch pad and 22 miles in altitude, traveling 2,700 miles per hour. All three main engines are working just as expected. The three fuel cells are generating power, and the three auxiliary power units are all producing pressure. In short, everything performing well. 2 minutes and 7 seconds into the STS-131 mission.
103 converged.
The booster officer in the Mission Control Center has confirmed the solid rocket booster separation. All systems continuing to function well. Two orbital maneuvering system engines on Discovery's tail are now firing as well, providing the shuttle an extra boost into orbit. The engine burn will last 1 minute and 44 seconds.
Discovery, 2-engine TOW.
Discovery copies, 2-engine TOW.
That call indicates that Discovery can now reach Morón in Spain should one of the three main engines fail. However, all three of those main engines are currently working well. 2 minutes and 59 seconds into the flight, and Discovery is now 79 miles away from Kennedy Space Center in Florida, 48 miles in altitude, and traveling at 4,500 miles per hour. Space Shuttle Discovery also seeing the first of many sunrises of the STS-131 mission.
Discovery Houston, you are negative return.
Discovery copies, negative return.
Discovery is now flying too high and too fast to return to the Kennedy Space Center in the event of an engine failure. That's not currently a problem, however, as all engines are continuing to perform as expected. 4 minutes and 15 seconds into Discovery's flight. Shuttle's traveling 6,000 miles per hour at an altitude of 63 miles and is 181 miles away from Kennedy Space Center. Environmental Systems Officer here in Mission Controls confirmed that the flash evaporator system has been activated to provide cooling to the shuttle system until the shuttle's cargo bay doors open and double as radiators.
Discovery, press to ATO.
Discovery copies, press to ATO.
Should two of the shuttle's three main engines fail after this point, it can still reach a safe, though lower than planned orbit, as that call from Capcom Rick Sturko indicated. Discovery is now 5 minutes and 42 minutes.
Discovery, you are single engine Ops 3.
Discovery 3.
67 miles in altitude and 351 miles away from Kennedy Space Center, Discovery could still make it across the Atlantic for an abort landing, even if two of the three main engines failed at this point. All engines are performing well.
Discovery, single engine, Zaragoza.
Discovery, copy. Single engine, Zaragoza.
Discovery now flying more than 10,000 miles per hour, 66 miles in altitude and 430 miles away from Kennedy Space Center.
Discovery, press to MECO.
Discovery, copy. Press to MECO.
And that call indicates the Discovery can reach its planned orbit of 136 by 36 statute miles, even if one of the engines fails. All three engines are still working well, as are the auxiliary power units and the 3 fuel cells.
Discovery, you are single engine press. Your shutdown plan is nominal. Go for the plus X, go for the pitch maneuver.
Copy. Nominal shutdown plan. Go for the plus X, go for the pitch.
Even if 2 engines were to fail at this point, Discovery could still make its planned orbit with just 1. That shouldn't be necessary, however, as all 3 engines are still performing at full capability. Also, Capcom Rick Sturkow there letting Commander Alan Poindexter know that Discovery will cut off its 3 main engines as planned and that he has the go-ahead then to pitch Discovery up to allow for photos of the external tank to be taken after its separation. Discovery now 7 minutes and 48 seconds into its mission, traveling at 15,000 miles per hour, 63 miles in altitude, and 730 miles downrange from Kennedy Space Center. Booster officer here in Mission Control is reporting that Discovery's 3 main engines have been shut off. We're now waiting for external tank separation.
Discovery Houston, nominal MECO, OHMS 1 is not required.
Nominal MECO, OHMS 1 not required.
There is the external tank separation. 8 minutes and 53 seconds into the STS-130 mission. Discovery now safely in orbit, 66 miles above the Earth, and traveling at 17,500 miles per hour. Also 1,065 miles downrange from the Kennedy Space Center.